My name is Lauren Mack, and this is my Lab 1, Constant Velocity. The purpose of this lab is to analyze an object moving at a constant velocity by using the observed change in position and comparing that with the predicted change in position calculated in Tracker as well as in GoScript. The predicted and observed graphs are expected to form a linear relationship between the change in position and the change in time, with some deviation due to human error. So in this experiment, I recorded a pencil being rolled across a flat surface. I then uploaded the video to Tracker and found the incremental positions by tracking snapshots of the object motion alongside a calibration stick that signified the entire area of, or the entire length of the area recorded. I used the initial time, the change in time, the initial position found in Tracker to calculate or to plug into the GlowScript computational model. Lastly, I compared both graphs generated from both models to display possible differences and similarities in the results. Also in Tracker, I chose to rotate the axis due to there being a curvature with in the pencil's trajectory that and the rotation of the graph made it so that the curvature was less significant when plotting points. So the main physics principle used in this lab is known as Newton's second law, otherwise known as the momentum principle, which basically states that the net external force of a system is equal to the change in momentum divided by the change in time. And with some rearranging, algebraic rearranging, you can find the final velocity of a system using the initial velocity. If you have the initial velocity, the net force, the mass, and the change in time. And with the velocity, you can find the position update with the position update formula. So in this lab, the system of this lab was the pencil, which is basically the observed phenomena that we were looking at, and the surroundings are anything that are observed. That are not observed as part of the system that interacts with the system. So that would be things such as air resistance, friction, and gravity. So to calculate the initial velocity for this lab, I took the final x position at the bottom of this range, and I took the initial x position at the top here, and I divided that by the total change in time because the velocity is supposed to be constant in this lab, meaning that the change in velocity in small increments will be the same or close to the same as the change in velocity over larger increments of time. So the initial values are seen here. I used these values to find the initial velocity, and I used the initial position in the x position as the initial position value in GlowScript, and I found that the mass does not affect the equation, so I set it to an arbitrary value. The initial time is the time that the object was first captured by in Tracker. But I set it equal to 0 because the change in time was the most important value. And the time was set to end after approximately 0.6 seconds in order to allow for more room on the graph, and the net force is 0, signaling that velocity cannot change. So what we found in this experiment was that the Tracker graph on the bottom displays the observed value, and the GlowScript model on the top displays the predicted values. The observed values curve over time, whereas the predicted values do not. The predicted values are meant to display the motion of an object with 0 net force acting on it. Since the bottom graph curves, this implies that there was forces acting on it while it was the system was in motion. In the video, the object curved because of an uneven force on the object, and it slowed down rapidly, which I am assuming is due to air resistance or friction. This motion is emphasized in the graph as the slope of the position over time becomes smaller and smaller as the pencil covers less ground. So possible sources of error include unlevel camera positioning, a rough surface leading to more friction, uneven initial force in the pencil, and the inaccurate Tracker data points. So what if the x-axes were flipped? If the pencil was rolled in the the negative x direction, the positive magnitude would be the same. The magnitude would be the same, but the direction would be different, so it would be negative. Can the observed net force components be calculated? The observed model not being linear could indicate outside forces acting on the model. This could be forces from the surroundings acting on the marker in the x coordinate. There's no accurate way to tell which components which components cause the interaction observed, because there are more than one at play, and this makes it hard to tell which force interaction has which value. And in conclusion, the constant velocity is predicted to have a linear relationship between the positive and the position and the change in time, and the potential errors and external forces could cause deviations between observed results and predicted results. Thank you.